Today we're going to talk about the IDS, what we would call the inverter ducted system. Kind of like a mini split, air source heat pump, but yet we now have ductwork matched up to an air drive machine, whether it's a gas-fired furnace or in this case, electric air handler. We've got an 18 SEER air source heat pump. There's my condensing unit and the one-piece air handler. Got a 10-year warranty out of the box. No registration needed. And if you're an ABC contractor, you've signed up on the Bosch ProHVAC.com website, you get your installations, you're going to receive additional 12-month warranty. Those installation, and you're going to be accruing points so that you can redeem them and buy Bosch products and rewards for those. And you also get put on the front page of the dealer locator. So when Mrs. Jones is looking for you, she'll be able to find you real quickly. Let's talk about the installation process. Here's my unit. It's a BVA 24. So we have 4 multi-position one-piece air handlers, the 24, 36, the 48, and the 60. In this particular application, it's upflow. You see that it is a 410A, and it's got a 410A expansion valve already installed in the coil. It is a 230 volt single phase air handling device. Inside this device has an X13 style blower motor. Basically what we would say is a 5-speed. You choose 3 of those speeds. There is my different sizes, widths, heights, and depths. One of the nicest things about the width on the 060 is that it is a 22-inch wide, not like some manufacturers, and they have only a 24-inch wide to offer. The 22 will go up through that scuttle hole in the hallway for easy access to the application in the attic. When you're wiring up my outside heat pump to the air handler, let's use a thermostat that what we would be called simple. This particular thermostat must be a heat pump thermostat. It is going to be a dedicated C thermostat and not a power robbing thermostat. And in the simple process, we would like to say that we don't want a thermostat that has a thinking logic behind it. Again, let's use a simple thermostat. And if you're only going to use this in the air conditioning mode, I just need 2 wires running out to the condensing unit. Give me a Y, give me a C, I'll work as an air conditioning system. If we're going to hook it up as a heat pump, add to those 2 wires a B operated reversing valve and also a W wire for defrost. We're going to hook my system up to a fossil fuel device. Here is a cased coil that you can use, multi-width, multi-depth, multi-BTU capacity, and also multi-position. It is aluminum coil inside the case. We have copper stubs sticking out for easy brazing and application installation processes. On a gas-fired furnace, here's a way that you could wire it up. Remember that I need a simple fossil fuel thermostat at this point in time, making sure that the gas-fired furnace and the outside heat pump does not work simultaneously. Dedicated C, give me a B for reversing valve, and get a W wire for the defrost, Y wire for my compressor, work like a champ. BOVA 60 that is you're seeing here is my 5-ton unit. Remember that I have also a BOVA 36. So I have 2 different condensing units, 2 different SKUs if you don't mind. It's a heat pump. It is 410A refrigerant. I'm using 208, 230 single volt power, 18 SEER efficiency ratings. And I also have a compressor inside that is a Mitsubishi compressor, a compressor that is tried and proven in our industry. This particular system has a very small footprint. If you don't mind, 29 by 29. Front and back, the height on the 3-ton is 25. The height on the 5-ton is 33 inches. So this thing can be set, placed, almost anywhere. You don't have to move it to, if the condensing unit that you're replacing is now going to be underneath the window, you don't have to remove the gate post to get it in the backyard. A lot of people say, well, Fred, where can I sit this unit? Where can it be located? And I really tell them all the time, I said, listen, just anywhere you want to. It's got 56 sound decimal to it. That is quiet as a quiet dishwasher. So in the process, it's a small footprint. It's a very, very quiet 18 SEER heat pump. The line set that we're going to attach the heat pump to the indoor sections are very, very simple. The BOVA 36 is 3/4 and 3/8. It's separated by 100 foot of line set if you need that, and you can lift one of those items 50 foot in height. The BOVA 60, which is the 5-ton, is 7/8 and 3/8. 100 foot separation again, lift them 50. Again, you do not have to insulate the liquid line. My unit does come with a Biflow 3/8 liquid line dryer. Would like for you to put that somewhere into the refrigeration circuit. Let's talk a little bit about the operation. A long time we've had a variated blowing device, and we've had a single speed compressor that we tried to apply comfort to our structures. Sometimes we did a good job. Sometimes we opened up the panel and we saw the green and black mode inside the air handling device going, well, we did a very, very good job. Today, we have a single speed air moving device that's going to allow us to program to give 350 CFM per ton. And my compressor is no longer a single speed, but it's actually an 85 step, an 85 geared compressor, allowing us to utilize that indoor unit as a sensor, allowing us to sense what's going on in the comfort range that is happening inside the structure. And my compressor will communicate through the board and modulate accordingly. Here's how we work. 230 volts, basically AC current is going to come into the condensing unit. I'm going to take that, I'm going to convert that to DC voltage. At that point in time, I'm going to invert the DC voltage to allow my compressor to see an inverted, a DC 3-phase voltage so that I can manipulate, modulate my compressor, always starting at the lowest denominator and changing accordingly to the comfort demands of the sensor. A lot of people would like to say, well, hey, my lights blink every time my unit comes on. That's how I know it comes on. This particular system, you'll never see the lights blink, and here's why. A lot of other systems will start at a very high amp draw. The inrush current could be as much as 60 amps. Well, I'm gonna try to fix that. I'm gonna try to combat that with a hard start kit, something that's going to take that and reduce those amps. If I had a Copeland compressor, I might even be able to put a soft start kit on that particular device. Anyway, I'm always going to be starting somewhere around the 21 to 18 amps. Again, having the possibility of dimming the lights. My particular system, whether it's a 5-ton, whether it's a 3-ton, always starts at the lowest denominator of the amp draw. My unit will always start less than 2 amps. And then going toward the comfort level that you need. Well, how do I communicate? My unit comes out of the box with the logic of looking at your sensor, looking at that indoor unit with the 47 degree saturation temperature in mind. So what I'm going to do is I'm going to look at that target temperature, and I'm going to modulate up and down so that my refrigerant saturation temperature is going to be 47. At that particular time, if I need a little bit colder coil, if I need a little bit more latent heat removed, I can turn the unit off, flip the switch, make that logic on that unit, change it to a 37 degree logic. We call that enhanced mode. Didn't change anything the refrigeration process, didn't change anything with the indoor air drive machine, just change the switch. The switch right there is indicated by that yellow line. This is my board. A lot of people at this point in time go, whoa, that's a board. I tell people all the time, this is not your grandpa's unit. What you're seeing there at the 65, that particular number, if my unit was off, that number would be recording the outdoor ambient temperature. If the unit was on, that particular number would represent the frequency or the hertz rating of my compressor. So where the yellow arrows are, those are 4 dip switches. I have the chance to what we would call dial in my unit if I needed to. The buttons on the right hand side, or the force button on the right, the check button on the left, those particular buttons allow me to take this particular page, look at the left hand side of this page, and I can push that check button and I can record, I can see, I can diagnose, I can take a look at what's going on inside the system, just like a doctor would do with an x-ray. And I can now look at this particular system and push the button 8 times and see the evaporator tint. Punch the button 16 times and see the compressor amp draw. Punch the button 23 times and see the last fault code. Again, Grandpa couldn't have done this. This particular board does a lot. This particular board will allow me to see what's going on, whether the machine is running properly or if the machine is faulted out and it's giving me an error code. That error code would show up there on that display. I would be able to take the book, find the error code in the back of the book, and walk through the diagnosing flow chart of that particular error code, allow me to find the error, what's the problem with the system, fix the system instead of just maybe doing the parts change out scenario until I got it fixed. Again, it's a very, very nice particular situation to look for in the IDS 18 SEER heat pump. Thank you very much for this short presentation. Hope you're having a great day. Thank you again.